What is going on, everybody? Back for another video. We got a nice little problem here. Let's see if we can work it. It says find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. We've got y equals sine x, y equals cosine x, x is between 0 and pi over 4, about the line, and we're going to rotate this about the line, y equals -1. All right, so let's get started. So the first thing we need to do is we need to graph this thing. All right, so there's 2 pi, 3 pi over 2, pi over 2. So for sine, our graph, and I mean, we don't need the whole graph, but we're going to just draw it all out. And that's not very good, but it gives us an idea. All right, so this is y equals cosine x, and this one, that's the top one here, and then this bottom one here that comes like this. I'll tell you what, let's do this. Let's draw sine in a different color. And this is y equals sine x. And we are going to rotate this thing about the line y equals -1. This is the line we're going to rotate it about. All right, so let's go ahead and draw in our rectangle here. We're going to use the washer method. Now remember, for the washer method, and I'm going to move this -1 right here just to get it out of the way. All right, so we need the outer radius to that rectangle, and we need the inner radius. So the radius here is from the line to the nearest point on the rectangle and from the line to the furthest point on the rectangle. All right, so if we go, let's do the smaller radius. So that's going to be from this line up to here. So we're going 1 plus whatever sine x is. So that's going to be sine x plus 1. And then from the line to the outer part, we're going up 1, and then we're going up to the cosine function. So that's going to be cosine x plus 1. All right. All right. So now our volume is going to be pi times the integral, 0. And what are we going to? There's pi over 4 right there. That's where they intersect. Because remember, that's when sine x is equal to cosine x. If we divide both sides by cosine x, that's going to give us sine x over cosine x equals 1. So we've got tan x equal 1. And tangent x is 1 when what? When x is pi over 4. All right. All right, so we are integrating 0 to pi over 4. All right, now remember, so we're using the washer method, so it's going to be the outer radius. So that's going to be cosine x plus 1. So it's the outer radius squared minus the inner radius, sine x plus 1 squared. And we're integrating with respect to x. That's the width of your rectangle there is dx. Okay, it's times the width of the rectangle. Remember, it's pi times the outer radius squared minus the inner radius squared times the thickness of the rectangle. Thickness of the rectangle is dx, so we know our functions are going to be in terms of x. All right, So this is going to be pi times, and that's going to be cosine squared x plus 2 cosine x plus 1. That's when we square this out. Remember, cosine x plus 1 squared is cosine x plus 1 times cosine x plus 1, and we just FOIL that out to get this. And then same thing here. Remember, that's sine x plus 1 times sine x plus 1. We FOIL that out, and that's going to give us minus sine squared x plus 2 sine x plus 1 dx. All right. All right. So let's see what we get here. We get pi times, look what I forgot, times the integral 0 to pi over 4 times the integral 0 to pi over 4. That's going to be cosine squared x and minus sine squared x. Okay, we're going to put those together, and then plus 2 cosine x minus 2 sine x. I got to distribute the negative, and then we've got 1 minus 1 is 0. All right, and so that's with respect to x, that's dx. All right, now how do we go about doing this? All right, so we could integrate cosine squared and sine squared using those power reduction formulas, but there's no sense in that because we know that cosine squared minus sine squared is cosine 2x. That's your double angle identity from trig. And then plus, see this right, let me see. This right here is cosine 2x. All right, and then we've got plus 2 cosine x minus 2 sine x dx. All right, now we're ready to integrate. So this is going to be pi times, and this is going to be, let's see, that's going to be 1/2 sine 2x. That's the integral of this. You can use basic u substitution. You can say let u equals 2x, du is 2 dx, and you can use that. But you should know that this is 1/2 sine 2x. You should know that. The antiderivative cosine is sine, so that's the sine 2x, and then times 1 over this number in front of x here. All right, and then we've got plus 2 sine x, integrate this next term, and then integrate this one. So the integral of sine is negative cosine, so that's going to make it a plus 2 cosine x dx. All right. I'm sorry. That ain't right. We integrated it. All right. And now let's plug everything in. So that's going to be pi times, that's 1/2 sine. Now when we plug the 1/4 in, we've got 2 times pi over 4 is pi over 2. So that's the sine of pi over 2. And then plus 2 sine pi over 4 plus 2 cosine pi over 4. Minus, I'm going to come down here, minus, now we plug the 0 in. 1/2 sine, 2 times 0 is 0, plus 2 times sine of 0, plus 2 times cosine 0. All right. All right. Now, we've got pi times, now the sine of pi over 2, this is 1. So 1 times 1/2 is 1/2, plus 2 times the sine of pi over 4 is square root of 2 over 2, plus 2 times cosine of pi over 4 is square root of 2 over 2, minus sine of 0 is 0, sine of 0 is 0, cosine of 0 is 1. So that's going to be minus 2. Now let's write it all out. That's going to be 0 plus 0 plus 2. And so we're going to get pi times, now that's going to be 1/2 plus 4 square root of 2 over 2 minus 2, which is pi times 1/2, times 4, times 4 square root of 2 over 2 minus 1/2 minus 2 is 3/2. And so we are going to have, let's see, how do we want to rewrite this? How about we factor out a 1/2? So that's going to be pi over 2 times 4 square root of 2 minus 3. And that's your answer. So, you know, it's not bad. The integral's not bad, especially if you remember this identity right here. All right. So I hope that video helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.